Right, so what we have here is a circuit with points A and B and a bunch of little resistors, which are all 1 ohm. We have a main path that goes through this resistor, splits off up here, and a little side path that goes down here and splits off again, and so on. We want the equivalent resistance of the entire circuit from point A to point B. What we can realize to solve that is that this little bit down here, the side path, is kind of the same as the entire circuit. And because this goes on infinitely, it doesn't matter how many times we doesn't matter how many times we zoom in, it'll always look the same. So what we can do, we can set this little side path down as x, and then we can say that we want to solve for Rx, which is just going to be the same as our R total because of that recursion. So let's start up the equation. We want R total, which is really just Rx, equals to 1 ohm plus the parallel portion, 1 over 1 ohm, which is this resistor up here, plus 1 over Rx, which is our side path. Now we kind of want to extract all the Rx's into the same place. So to do that, what we can do is to multiply this portion by Rx over Rx. So we can say this is 1 over 1 plus Rx over, we can distribute the 1 down here, we have Rx times 1 over 1 plus 1 over Rx. And we can kind of simplify this into into Rx plus 1, of course, equals to Rx. But then, over here, we can move the 1 across so that we get Rx minus 1 equals to this portion over here. Now, at this point, we can probably move things a lot more cleanly. So we have, Rx minus 1 times Rx plus 1 equals to Rx. Or in other words, we get 0 equals to Rx squared minus Rx minus 1. Now you might notice that this quadratic is awfully similar to the golden ratio phi. That means that our Rx is actually the golden ratio phi. Now there are two solutions technically to this quadratic. We have negative 0.618 or positive 1.618. Now clearly the resistance can't be negative, so let's just cross this out, and now we have our answer, positive 1.618 ohms. And there we have it. So, for question 2, we have a similar setup, except it's slightly different in that now, instead of being nested like inside each other, we have the resistors going infinitely along to the right. We have a similar setup in that we have a main path, the shortest path here, but then some other side paths through the same two resistors, through this longer little circuit here, and then through this even longer bit here. We still want our total, the total resistance between resistor A and resistor B, and we can use a similar technique to solve for it. Now, we can, again, realize that we can cordon off this little bit here, going on to infinity to the right, and this will look a lot like the whole thing, because we can, again, zoom in infinitely, again and again, and it'll be exactly the same. So to start up the equation, what we have here, we will end up with Rx, our R total, equals to 2 ohms, because now we have two resistors in series plus the parallel portion of this equivalent resistor and this other resistor. So we have 1 over 1 again for this resistor plus 1 over Rx. And then, of course, similarly, we can solve by multiplying Rx upon Rx. And of course, Rx and Rx cancel to give out 1, right? We'll end up with, no ink, okay. Rx equals, actually, Rx minus 2 will equal Rx on top of Rx plus 1. Because again, those cancel in a similar way. So we get Rx minus 2, Rx plus 1 equals Rx. We can expand this to get Rx squared minus Rx minus 2 equals Rx. We can collect this over to get 0 equals Rx squared minus 2Rx minus 2. And then we can plug this into the quadratic formula, which is going to be Rx equals to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So we have negative of negative 2 plus the square root of negative 2 squared plus 4 times 1 times negative 2 all over 2 times 1. So what we have here, we get Rx equals to plus or minus the square root of this ends up being 12 all divided by 2. So we can simplify this to equals to get Rx equals, and once again we can ignore the negative because it's resistance, equals to 1 plus the square root of 3 in ohms. And there we have it.